Rather unfortunately, I had created a video for this and the audio did not work. So this will be a slightly abridged re-recording of the week 1 10th topic, arrays, slightly advanced. The reason it will be slightly abridged is because a lot of the material that I was talking about anyway actually will be re-explained in the coming week's material. So because of that, it didn't seem to make a whole lot of sense to me to go fully deep again into this, knowing that having already recorded week two's material, you will hear a lot of it again. So just quickly, we're just going to look at a couple of sort of last advanced features surrounding Java arrays. And we're going to be specifically talking about copying arrays. So this again will come up again when we talk about objects next week, when we talk about copying them, as well as in the week following. So over the next 2 weeks, we're going to talk about this again. But let's just start by looking at how not to copy an array. So here we can see that we've made a new array, my array, and we have 3 elements in that array. I've hard-coded the array to be 3, 5, and 7. And then in a new array, I declare my copy on one line, and then I set it equal to my array on a second line. Now, this assignment of an array doesn't actually give us 2 arrays that have the same amount of information in it. This is equivalent to me saying to you where I live. So if you said, hey, Lauren, where do you live? And I told you I lived at 123 Fake Street, and you were able to then go to 123 Fake Street and come to my house. And you'd have access to all the information that I have. You could see all my stuff, whatever it might be. This is equivalent to that. This isn't the same thing as what happens with update, like copying integers or booleans. So if you had like int x equals 5 and then int y equals x, you'd end up with 2 copies of the value 5. If we tried to do that with something like an array, that would be equivalent to you saying, where do you live? And me saying, here, I'll show you, and taking my whole house and giving it to you. Right? That's not what we're doing here, and making a whole second copy of my house and giving it to you. That's crazy. So when we do a shallow copy, it's just like passing an address around. It's just saying, if you want to see the kind of data I have, come check it out over here. And I give you my address. And so when it comes to arrays, we're not actually storing all that data inside the array. Inside that variable, we're just storing the address. We're just telling Java, this is where you can go look to see the data. Right? So when we do something like this, we don't actually get 2 independent copies of the array. We get 2 addresses to the same location. Exactly like if I were to just tell you where I lived, and then you were to come over and we'd be standing in the exact same house, because we'd be in my house. They all lead to the same address. What this also means is if you come to my house and you break something, I'll be like, hey, why did you break my thing? I'll be totally aware of it. When you modify an array, like my array, the array variable my array, if you were to change one of its elements, it would also affect my copy. So if you came to my house, you followed me to my address that I gave you, and you broke something in my house, I'd be like, hey, that was mine, and I know you changed it. So it's the exact same thing here. They both have the same address. A change to one affects both. If we wanted to actually get a true copy of an array, we do what's called a deep copy. And it's when we actually physically make a totally separate array of the exact same size as the original, as we can see we're doing here. And then we copy over using a for loop every single one of those elements right here. We can see like for each element in the array, let's copy it over. So when we first make it of that same size, we get all default values, 0, 0, 0, pardon me. And then here, when we actually do each copying of each element, there we're getting physical different copies. So when we use that new keyword back up here, we're basically saying, give me a new plot of land. Give me a new address that I can use to store my own information in. And then you can go into the my array, or in my house analogy, you can come over to my house. You can take a full copy of all the things that you can write down all the things that I have in my house and go buy them if you want them to be the same, and you can bring them over and copy them into your house. And then you end up with two houses that look exactly the same, or in this case, two arrays that look exactly the same. Instead of doing the for loop, there is a built-in function called system.arrayCopy, which I will go over again either not next week, I think it's the week after. But it's basically a shorthand way of doing this for loop, only with parameters and a built-in method, where we have my array, which is the source array, the starting element in the source array, the destination array, the starting element in the destination array, and then how many elements you want to copy over. But it's literally doing the same thing as the for loop would be doing in most cases that we use it for. It's kind of, I'll actually flip back for a second and say more on that. So the for loop here is pretty small, but sometimes it can be kind of annoying to do, which I recognize and understand. And then we have this alternative to the for loop down here, but sometimes people find it a little bit complicated to follow because there's just not a lot of information there. It's worth noting that there are other types of shortcuts that we can take when it comes to for loops. So this doesn't quite work for copying arrays, but it is a shortcut to for loops. If you have a for loop where you're just like printing out all the information, where you don't care so much about the index of the information, you just care about the data that's inside, like maybe you're just adding up all the elements or returning one of the elements or checking to see if something is in it. We just need to go through each and every single one regardless of their index. We can use what's called a for each loop, where we have for each element in the array. So if our array is called data, we can say for each int element, so for every element will be the variable we have access to, colon in data. So for every element in data, and then we can use element just as if we would use data at I. It's much shorter and more elegant looking to the for loop above. So that's really all there is to this sort of advanced conversation right now. We're going to do a lot more conversation around deep and shallow copies to come, but it's sort of nice just to understand what's happening here so that when you go and write functions and pass variables into these functions, perhaps you pass an array into a function, it's important to understand that what you're passing in is an address, not a full separate copy. So to do some practice here, I've got sort of a way for you to make some different arrays, practice changing them, copying them, a deep copy, a shallow copy, using a for each loop to display the array, all that good stuff. So give it a shot, and then coming up in the next week, you'll see a little bit more of each of the types of copying and more on even the alternative for loops as well.